You light our homes. Keep us warm.
You help us explore, innovate, and achieve the unthinkable.
You are everywhere.
Yet, sometimes out of reach.
You move us forward and bring us together.
And together, we're on a journey towards the future of energy.
So what will it look like?
It's hard to say, but we know it will be sustainable and abundant.
We're already on our way.
With a common purpose, each of us playing our part.
At Deloitte, we're connecting every bright mind, every organization, every startup, every innovator.
Every citizen, CEO, and regulator.
Making this future happen won't be easy, so we're developing practical solutions.
And a clear roadmap to help our clients on their way.
We'll keep making those connections
Each step well planned, moving forward together.
to make our new energy future a reality. Let's connect for a new energy future.
I would like us to swiftly move on to a representative of the Słupsk local government to tell us how the city of Słupsk is getting ready for the hydrogen revolution. What can you tell us? Welcome, ladies and gentlemen. Briefly, for you to get familiar with the project, somebody has to generate hydrogen for those buses. And I think that's the municipal model that we would like to propose matches the strategy of hydrogen transport. You cannot really transport it over long distances, or it is not efficient, effective to do so. So those production plants should be in the vicinity of 100, 200 meters from the place where they would be distributing hydrogen from. I would like to show you that those communities, power communities described in Red 2, those that the directive on community power-related rules can become a nice accelerator for the local initiatives within which hydrogen is a certain tool for balancing energy. Here I'm showing you a project that we've been implementing, 15 mega of wind. We have biogas with a biofermentation plant, as we've heard from the representative of Orlen. We've got photovoltaics, we've got cables, we've got the heat transportation option, and we've got certain adhesive that brings producers together and the market together with the producers, particularly today that we know what the prices are like. And if you could flick over to slide 2 so that you could see where hydrogen fits in this project of hydrogen community, and why is it a municipal project? Well, treatment plants are a very interesting place, particularly in Słupsk, where we have gathered certain potential in which treated waste can be part of feeding the electrolyzer installation. The side products such as oxygen or heat can be managed, improving certain economic efficiency of the project. Oh, we've got service on the spot, we've got biogas, we've got options of storing hydrogen or getting it out of the waste, and we've got promising talk results with a few partners about the market that is in demand or that has a large demand. And talking about an energy mix, there's drops and peaks in which you need to manipulate with energy. It seems that such a project that is developing as the market develops locally could be implemented, and such a project will lead to the creation of real potential, and it would also make it possible for those interested in buying the buses to actually do so. Thank you very much.
Państwa, żeby Słupska, żeby inni mogli zobaczyć, co się da w łatwy sposób zaimplementować w konkretnych warunkach. Ale samorządom potrzebne jest nie tylko wodór, nie tylko autobusy, ale może inne pojazdy. I chciałbym prosić pana Krzysztofa Sosnowego, żeby powiedział o tych innych pojazdach.
Other vehicles as well. That's why I'd like our colleague to tell us about other vehicles powered by hydrogen, which can be used by municipal governments. Thank you very much. I represent a company from Pomorskie Województwo. We are located in Rakowo Górne, nearby. So if any of you are traveling in the direction of the Hel Peninsula, then on the left-hand side, you can see us quite easily. Our company is part of a larger group. We're part of the Kirchhoff Group, which is represented both in automotive sector as well as in two main companies, Found and Seller. As part of the Found Group, a company was created which develops and implements on the market electrical hydrogen platform. platform chases. Just to remind you of the Electromobility Act, which will force appearance of zero-emission, low-emission fleet. So initially, the municipalities over 50,000 were taken into account, but in novelization, all municipalities will have to be involved. These are different percentages, but generally speaking, it includes all the municipalities. And we have to bear it in mind, because there isn't that much time to complete it, because these are certain percentages that have to be carried out. If a given company is not going to fill these limits, then of course the contract can be dissolved. This applies both to waste management as well as public transport. So in case of buses, these requirements are very high. We can see it already. For example, Gdynia here just bought electrical buses, same Gdańsk recently. I'm not going to talk too much because my colleague Tomek said quite a bit about his bus and the technology we used in our chases is quite similar. The philosophy, the idea is very close. I know we're running out of time, so I won't spend too much time here now. Moving on to one of the slides which shows that hydrogen is really treated as an energy storage element. Of course, there is a lot of questions, a lot of doubts, whether it should be produced as as a source of energy, but it can be seen in the schematic. If you're talking about electrolysis, we can see a lot of electricity to store energy. 1 kilowatt hour of energy is needed to accumulate 1 kilowatt hour of hydrogen. This decreases in the process from 1 kilowatt. In case of our vehicle, there is only about 600 watt hours of energy that remains, so the effectiveness is quite low. One thing is certain, hydrogen is one of the alternatives for energy storage. We won't be able to use only electrical systems. Electrical grids have no chance of being efficient enough to transport, store the energy which we will be needing. Maybe I'll show you the last slide because it shows how the vehicle is built. We are cooperating here with Mercedes, who are using basically already chases without any power components. We've selected this chases because from construction point of view it's ideal for its character. That is the low cabin. It's very easy to enter exit cabin, which is important, and also it fits the system we want to use and the vehicle. When all the components are placed, it's comparable with traditional diesel vehicle. What's important, what we used here is the possibility of modular construction of the vehicle depending on need. A customer can have 1 or 4, up to 4 hydrogen tanks. We're using hydrogen fuel cells of 30 kilowatts in power, and we can have 1 or 2 or 3. It all depends on how the vehicle is operated, what's the actual need for energy. If it's operating in city mode, then energy requirement is less because recuperation takes place. However, there are further distances to travel, then generally more fuel cells are needed. We've used a tank for 700 bars. In our view, this allows for maximum use of the tank, the tank volume, which affects directly the range of the vehicle. Some illustrations showing the fuel cell, the batteries, the high voltage switchboard and so on. Thank you very much for your attention. Thank you for this brief presentation and time discipline. There are two questions that I'd like to ask. When do you think we will have in real operation in Poland on larger scale your vehicles or other vehicles of this type? Let me try to answer by quoting some facts, because generally speaking, we've been interested in low emission, zero emission for a long time. The first projects we've done together with Danish companies, this was fully electric power in our system. This is something we've been providing to the market since 2010. I saw very interesting electric chases produced by Swiss Futuricom, designed verb under Futuricom name. It was a project financed completely by the Swiss government, which in the through a tender process selected a company which was to provide 4 electric garbage trucks. A lot of involvement both in Switzerland and Denmark, a lot of interest on the government side. I think we were lacking that. We are lacking that somewhat. So when I was listening to Tomek and his enthusiasm, I think this is what drives us, our own enthusiasm, our own engagement in carrying out such projects. The design of this hydrogen vehicle in Germany started in 2016 in Germany, started to be done. However, the idea itself started much earlier. So I think we're a bit behind. We all have some catching up to do. It's definitely ahead of us. We have to follow in tracks of what has already been done in the West. We're a bit behind, but that can be to our advantage because we can avoid certain mistakes. We can accelerate the implementation process because no project, big electric or hydrogen, is easy or it's easy to implement. You need a lot of knowledge, a lot of experience, and mistakes appear which need to be eliminated. And the development of this hydrogen vehicle was also slowed down by pandemia, both when it comes to availability of components, and the fact was also that it's difficult to do such projects online. Summing up, however, last weekend I was in Bremen, in Germany, because that's where the company is located, where we mount these chases, and there are 2 hydrogen stations in Bremen, generally available, commercial stations, fueling stations. And these hydrogen distributors are the regular public stations. So you can go to the station, you can get LNG, you can get hydrogen, you can also charge your electric vehicle very quickly. In your offer, do you foresee an offer which is made of both the hydrogen and bus, or just the vehicle? We concentrate on chases itself, on the vehicle itself, because both hydrogen supply and building of stations or production of hydrogen, we think that these are not our competences. Thank you very much. At this point, I'd like to ask, as part of a more scientific view, Mr. Grzegorz to tell us about more practical, Mr. Grzegorz Orlikowski to tell us about legal regulations which can be used by self-governments. Generally, he'll tell us about guidelines regarding safe distances and hydrogen fueling. What my colleagues have talked about testifies to the fact that hydrogen transformation is in progress. This hydrogen transformation also includes the asset technology group, which is made, among others, by the Eko-Konsult group, which I represent. And it's also made of EPRORAF as part of this group, this technological group. We've carried out many projects from environment safety, process safety, fire safety, explosion safety. areas. Here I'd like to point to some of the more interesting ones dealing with, for example, construction of electrochemical fuel cells, which can also be working in an electrolyzer mode. Another interesting application is fueling station, car fueling station, passenger car fueling station, which is connected with a module for charging forklifts fueled by hydrogen. All these installations presented here, they should be designed in a safe way, including also proper distances from other infrastructure. In case of construction industry, we have regulations regarding how far from each other to build structures. In case of traditional fuels, we have also quite precise guidelines presented in appropriate regulations. However, when it comes to hydrogen stations, we don't have such unequivocal legal guidelines. So at today's presentation, I'd like to present the way of Eko-Konsult, of how the company provides appropriate safety, appropriate distances on part of hydrogen infrastructure from other objects. In the topic, it was said that this presentation deals with hydrogen stations, but these safety rules also apply to other hydrogen installations. For example, some hydrogen tanks standing next to a hydrolyzer, which later will be loaded up and taken to other installations which use this hydrogen. Let's take a look at the components of hydrogen fueling stations. Usually such a hydrogen fueling stations is made of a production module. In other cases, hydrogen will be provided by vehicles providing hydrogen tanks with compressor, which will compress hydrogen to 350 or 700 bars from buffer tank, and then through pipes it is brought to distributor. Now, in designing hydrogen fueling station, we should specify whether these hydrogen installations are in fact in proper distance from the road, as we can see here, or from the plot border, where perhaps accidental passers-by will be walking, and from any other structures. Safe distances from other objects due to lack of legal regulations should be defined on the basis of appropriate technical standards. Here we presented two standards. The first is ISO 19880-1. The second one is NFPA2. In my presentations, I'll try to share with you the regulations based on the ISO standard. Why? Well, in accordance with the decision, which was already referred to a number of times today, regarding technical requirements on hydrogen fueling stations, and we see the draft of this decision, this resolution here on the slide. Hydrogen fueling stations should meet technical requirements in accordance with current state of knowledge and best practice, especially with regard to norm 19880/1. So we have direct indication here. So here, as a consulting company, we suggest using these regulations, these guidelines. What is a safe distance? Safe distance is a place, actually a distance at which the level of risk is acceptable. In the nomenclature in professional literature, we have various definitions of safe distance. For example, restriction distance, core distance, installation layout distance, protection distance, external risk zone. At today's presentation, I'd like to present two types. That is external risk zone and clearance distance, and present examples. In accordance with the content of the ISO standard was quoted, safe distances can be taken from national regulations. However, in Polish conditions, we don't have clearly defined safe distances, or we can use quantitative risk analysis, the so-called QRA analysis. Here we have an example of the safe distances, where we see the ISO risk curves, which illustrate the probability of fatal accident around this installation. Now, the benefit of such quantitative analysis is that it generates safety distances which are adequate for a given station. Let's imagine a big station located at some node, let's say near Gdynia, in which we have an installation in which there is a lot of hydrogen that's stored. Intuitively, we fear that these safety distances will be quite large. For contrast, let's imagine a tiny station somewhere where we have a small amount of hydrogen. And here also intuitively we feel that in this case the distances should be smaller. So based on this quantitative risk analysis, we can prove which safety distance should be given for a given, should be set for a given fuel station. Now we can use risk measures in assessing risk. The ISO standard presents proposals that we can use, and this ISO norm here is based on average individual risk, AIR, and we can see that they are from 1 to 10 to -6 per year. That is the risk of death. And now, according to the ISO standards, we can also set these safe distances based only on physical effects. And here the norm also presents what are these criteria. Here we can see the values of thermal radiation, kilowatts per square meter. As the first type of safe distance, let me show is the so-called external risk zone. This is an area or zone outside of a fuel station which should be protected against threats created by fuel stations.
Just for example, the area of the fuel station from the border with an allotment to which a person can come that is not actually related to the station in any way. And the analyses that we perform within the projects implemented in the Asset Technological Group for the qualitative risk analysis, we use the HIRAM program. Here you can see a print screen from this program in which we present the way of complementing the data in such a way so as to enable the risk analysis. It boils down to writing particular parameters of given systems. For example, the number of valves on a hydrogen station was specified here as 5 items. Let's see what the possible arrangement can be for a fuel station. This is presented here in the form of a diagram. So let's say we analyze the C and B points, and we decide what the distance between C and B should be from the border of the allotment. Let's say that we've got pipelines, the diameter of 10 meters, we've got 23 valves, and the other parameters as presented, then the safe distance is 11.5 meters. Reducing the diameter, case 1b, seeing some updated assumptions, we see that it reduces the safe distance to just 1 meter. So we showed the impact of the risk analysis and the maneuvering with the safe distance depending what kind of system we are analyzing. Another example of clearance distance, the distance that I would like to discuss, and let me remind you that there are five of those, is the very clearance distance. This is a distance between particular pieces of equipment within the fuel station and a particularly threatened components of the fuel station. How to define the clear distance? Well, an example of establishing how to set it is, for example, showing the hydrogen valves. There will be some pipelines. They'll will have to have their outlet, and we'll have to decide at where it should be located and what height. And what comes handy here is an ISO standard. In order to establish where we should have this point, this output, we need to have two analyses. First one is about thermal radiation created by the flame. The standards envisage that owing to a minimum ignition requirements and the features of hydrogen behavior, what might happen is ignition of this hydrogen. Therefore, we want to place it at such height that it does not endanger the workers, the employees. So the first analysis is a thermal one, so the impact of the thermal radiation. The other one that we need to carry out in order to meet the requirements of the ISO standard is the gas dispersion analysis. And this one is carried out in order to prove that should there be an explosion, the gas that has already diluted below the lower limit of explosiveness does not come across ignition sources like power lines or lighting. The drawing shows you such a drawing showing you the impact of radiation, thermal radiation. The one of 1.5 kilowatts per square meter reaches the level of the ground. So the conclusion is here that this outlet would have to be raised above the ground level. So much as for this presentation. It is just the tip of the iceberg concerning the whole topic of safe distances. I encourage you to get in touch with me should you require further information. Thank you very much. Applause. Ladies and gentlemen, thank you very much. Owing to the time limits, we need to cut it short.
Jesteśmy największą metropolią w Polsce Północnej. Jesteśmy otwarci na to, co nowe. Jesteśmy świetnym miejscem do życia. Jesteśmy Trójmiastem i dlatego zawsze będziemy dbać bardziej.
Korki na wszystkich drogach dojazdowych do Trójmiasta już dawno przekroczyły akceptowalny poziom. Dlatego samorząd województwa pomorskiego uruchomił nową linię kolejową łączącą metropolię trójmiejską z Kaszubami. Dzięki podróży pociągiem tysiące osób może szybciej i wygodniej dojechać do pracy, szkoły lub na zakupy, a potem wrócić do domu. Nie trać czasu i pieniędzy w korkach. Podróżuj szybko i wygodnie koleją. Do pracy, do szkoły, na zakupy.